Now we'll do a third example, and this example is going to illustrate what happens when the discriminant is 0. So example 3, let's try the equation y double prime plus 4y prime plus 4 equals 0, and we'll use the same initial conditions we have previously. Just for comparison. If we substitute the y equals a e to the rt, we see that we get the characteristic equation, and I'm not going to go through the steps. We've seen those steps numerous times. Okay, we get the characteristic equation r squared plus 4r plus 4 equals 0 with solutions r equals -2 and r equals -2. There are two ways to see why we get the solution twice. Solutions of the quadratic equation would be r equals -4 plus or minus the square root of 4 squared minus 4 times 4 divided by 2, which is -2 plus or minus the square root of 0. So that's -2 plus 0, or -2 minus 0. So there are actually two solutions, one for the plus, one for the minus, but they're both going to come down to -2. So we get the two solutions, r equals -2 and r equals -2. Alternatively, this equation is easy to factor. We get r plus 2 times r plus 2 equals 0, so that r plus 2 equals 0 is one root. It gives us one root, and r plus 2 equals 0 gives us another root. Each of these gives us a root. So the root here is r equals -2, the root here is r equals -2. So what we have is a repeated real root, r equals -2. One solution to the equation then is clearly y equals a e to the -2t. We need another solution to get the general solution. Well, our quick trick the other solution is y equals a times t e to the -2t. That is, we just put a t into our solution. So now we have two solutions, and we can call these solutions y1 and y2. So that our general solution is going to be y of t equal y1 of t plus y2 of t, which is going to be a e to the -2t plus b t e to to the negative 2t, where I use b instead of a because these constants are arbitrary constants. A is arbitrary here, A is arbitrary here. We don't have to choose the same constant for both solutions, so we'll call one of them A and the other B. Now, I've quoted this quick trick. I haven't motivated it. I haven't shown you where it comes from. We'll do that in a subsequent clip. But for now, we'll just accept this trick and move on. So we want to apply the initial conditions. Okay, well, one of the initial conditions is on the derivative y prime, so we know that y prime of t equals negative 2ae to the negative 2t plus what? Product rule, t e to the negative 2t. The derivative of t is 1, so we get be to the negative 2t. And then we get plus negative 2 bt e to the negative 2t. And things got a little crowded there. That's kind of illegible. But we can bring this down here, and we see that our solution is negative 2ae to the negative 2t plus be to the negative 2t minus 2bt e to the negative 2t. We don't need to do it here, but notice that we could, of course, factor out the e to the negative 2t. So we have just 3 terms adding up to the coefficient of e to the negative 2t. Our purpose here, though, is to apply the initial conditions. So, first initial condition is y of 0 equals 1. Y of t is this, and we'll simply point e to the negative 2t is going to be e to the 0, which is going to be 1, so we're going to get a. And bt e to the negative 2t is 0 because t is going to be 0. So 0 for t gives us 0. The result being a plus 0 is 1, so that a equals 1. Now let's see. Y prime of 0 needs to be negative 1. So what do we get for y prime of 0? Again, I'm not going to go through every detail of the substitution. I'm just going to kind of wave hands and point because it's a very straightforward substitution. We put in 0 for t. All the exponential, the e to the negative 2t's are going to be 1. This term is going to be 0 because 0 substituted for t gives us 0 in this term. So we're only left with these 2 terms, and we pretty easily see that the equation we get is negative 2a plus b equals negative 1. Y prime of 0 is negative 2a plus b, just substituting 0 for all the t's, and that's equal to negative 1. So, a equals negative 1. I'm sorry, a equals plus 1. A equals 1, so we're going to get b equal to what? Well, we have negative 2 plus b equals negative 1. If we add 2 to both sides, we get b equals 1. So that our solution to the equation with the initial conditions is what we get if a equals 1 and b equals 1, and that's simply y of t equals e to the negative 2t plus t e to the negative 2t.